This problem is related to magnitude of equilibrium constant. Let us read this problem first. So basically we have to calculate increasing order of Kc, and in the first case without doing any calculation. So let us discuss part A. Let us say for situation number 1 we have equilibrium constant is K1, for 2 we have equilibrium constant K2, and for 3 we have equilibrium constant K3. If you see one important point, we have all the 3 boxes will have same number of spheres, that is 10 number of spheres. You can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this box has 10 spheres. Now let us this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this also has 10 spheres. Now this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this means all the three boxes has 10 spheres. Now what is happening in all cases? Basically all are equilibrium situations. So we have reactant, and this is going into product. Let us discuss reaction number 1. So in reaction 1, this red one is reactant. So 1, 2, 3, 4. So we have 4 reactant, that is 4 spheres. And we have 1, 2, 3, 4, 5, 6 sphere blue, and blue is the product. So we have 6 sphere as product. Now let us say reaction number 2. We have only one product, that is yellow one is product. So we have 1 sphere inside the product, and then we have 9 spheres as reactant. Now situation number 3, if you see, we have 2 sphere as reactant, that is blue one, and rest 8 sphere as product. Now equilibrium constant for this reaction is K1, for this is K2, and for this is K3. So we have to basically look which has more number of product. So the spheres we have to see in the product side. So K3 has maximum number of spheres in the product side. So basically K3 is greatest. And then we will have K1. And then we will have K2. So this is the order of equilibrium constant. So this is increasing order. Now B part says, now if the volume of container is 1 liter and each sphere represents 0.1 mole, calculate the Kc in each term and rank the values of Kc. Now let us say B part. Each sphere basically denotes 0.1 mole. So now we will have reactant here, and this goes to product. So I will have 1 sphere is 0.1 mole. So 4 sphere will be 0.4 mole in reaction 1. And this side we have 6 sphere, that is 0.6 mole. This is now mole. Now similarly we will have 0.9 and 0.1. So for reaction 2 this is 0.9, and this is 0.1 mole. Similarly we can do for reaction 3. In third case we have 2 sphere, that is 0.2 mole and 0.8 mole. Now we have to calculate Kc. To calculate Kc we have to convert into concentration. So let us convert all these moles in concentration. Now if you see the reaction 1.4 mole and the concentration is mole by volume, volume is 1 liter, so this is simply 0.4 m and this is 0.6 m. Now we can calculate Kc1, that is product by reactant, that is 0.6 by 0.4, that is 1.5. Now let us discuss reaction 2. Now I will have 0.9 mole per liter because volume is 1 liter, so 0.9 m, and here you have 0.1 m. That is K2 we can calculate product by reactant, that is 0.1 by 0.9. So this is 1 by 9 and 1 by 9 we can calculate, this is around 0.111. So this is 0.11. Now let us say reaction number 3. This side you have 0.2, this side you have 0.8. So this will become 0.2 and this will become 0.8 m. So K3 will be product by reactant, that is 0.8 divided by 0.2, and that is basically 4. So now if you compare the K values, K3 is 4, that is highest, and now if you see K1 is another one, the highest one, and lowest one is K2. So this is the increasing order. Now you see this value, same value, that is K3 is greater than K1 is greater than K2, we also found here, that is without doing any calculation. So basically we can compare equilibrium constant either qualitatively by number wise or quantitatively. So without any calculation we can also say something about equilibrium constant. Let us do this practice exercise. This is easy one. So we have to find at what temperature formation of HI is more favored, that is at higher temperature or at lower temperature. So you have H2 plus I2 and this gives you 2HI, all are gases. Kp is 794 and this time temperature is 298 Kelvin, that is room temperature. Now the same reaction we have and this time Kp we have 55 and temperature is 700 Kelvin. So you see if Kp is more, this means product is more. So how we write Kp? So generally we write Kp is equals to concentration of product and divided by reactant. So if Kp is large, this means concentration of product is large. So this means Kp is high. This suggests product is major. Now this means we have to compare Kp values. Now here we have 794, here we have 55. This means Kp is higher at this temperature, so Hi will be higher at this temperature, that is formation of Hi will be favored at 298 Kelvin, that is basically lower temperature than 700 Kelvin. So I can say formation of Hi is favored at 298 Kelvin and that is comparatively at lower temperature.